What if I told you that gravity, the powerful force governing planets, stars, entire galaxies, isn't fundamental at all? What if it emerges from something entirely different? From entropy, a measure of chaos and disorder in a system? Sound like science fiction? Maybe. But it's a fascinating, though controversial theory from the cutting edge of modern physics. Imagine spacetime not as an empty stage, but as a complex thermodynamic system. In this view, gravity isn't a force in itself, but a side effect of the system's tendency towards, well, more disorder, meaning increasing entropy. Mind-bending, right? Let me explain. At the heart of this idea is the work of Erik Verlinde, a theoretical physicist. Back in 2010, he proposed that gravity might not be one of the fundamental forces of nature, but rather an emergent phenomenon. It arises from microscopic degrees of freedom, the countless ways particles within a given system can rearrange themselves. Think about temperature. We don't feel individual, vibrating molecules, right? We feel their collective, macroscopic effect as heat. Verlinde suggests gravity might work similarly. It's a macroscopic effect of microscopic chaos, and that's where entropy comes in. Remember? It's the measure of disorder. According to the laws of thermodynamics, entropy in the universe always tends to increase. Verlinde argues that the distribution of particles across space-time creates an entropy gradient, and it's precisely this gradient, this drive towards maximum chaos, that pulls objects together. What we perceive as gravity might simply be the statistical tendency of systems to arrange themselves in the most probable, that is, the highest entropy, configurations. Not Newton's force acting at a distance, but thermodynamics on a cosmic scale. You're probably asking, wait a minute, what about Einstein and his general theory of relativity? Good question. Einstein's theory brilliantly describes how matter and energy curve space-time, but Verlinde argues this curvature might just be a macroscopic illusion, resulting from the statistical behavior of space-time's microscopic building blocks. Like the smooth surface of a coffee cup, which is actually made of countless vibrating atoms. What's really exciting is that this perspective might help solve one of the biggest mysteries in physics: dark matter. That mysterious substance we can't see, but we know is there because of its gravitational effects on galaxies. In Verlinde's framework, the extra gravity we observe in galaxies might not come from unseen matter at all, but from large-scale entropic effects. If that's true, it would be an absolute revolution in our understanding of the cosmos. We'd have to rewrite our astrophysical models from scratch. Need a simpler analogy? Imagine a crowd of people milling around randomly, but if suddenly free pizza appears over here, a more probable, higher entropy state, right? People will naturally drift towards it, creating a collective movement, an attraction. Gravity, in Verlinde's view, is a bit like that emergent pattern. The system naturally moves towards more probable, higher entropy states. You might ask, okay, that's cool, but what's the evidence? Well, that's where things get tricky. Scientists are actively studying the behavior of galaxies, comparing real-world observations against the predictions of Verlinde's model versus traditional dark matter models. The results so far are intriguing, but not conclusive. Some observations seem to align well with the entropic gravity idea, while others still fit better with dark matter. The jury's still out, but remember, every major scientific theory starts out this way. Verlinde's theory also touches on fundamental questions. What is space-time, really? Is it smooth and continuous, or grainy at the quantum level? Is it truly fundamental, or does it itself emerge from something deeper, like the holographic principle suggests? The idea of emergent gravity offers a completely fresh angle on these problems. Maybe space-time itself isn't fundamental, but just a construct emerging from a deeper, thermodynamic substrate of reality. And here's the kicker. If Verlinde's theory holds up, it would revolutionize our understanding not just of the cosmos, but of the very fabric of reality. We'd start to see the forces of nature not as fundamental interactions, but as emergent phenomena, shaped by the universe's relentless drive towards disorder and equilibrium. So, is gravity an illusion? It depends on what we mean by real. Is a rainbow any less real just because it's refracted light hitting water droplets? Physics constantly challenges us to rethink our concepts of what's real. The idea of entropic gravity is another fascinating invitation to do just that. Even if gravity is just an emergent effect, it's an incredibly consistent, beautiful, and functional one, arising seamlessly from the universe's deeper structures. One thing's for sure: the more we study the cosmos, the more mysterious and wondrous it becomes. If this has inspired you to keep learning, and I really hope it has, then go ahead and subscribe to the Hyperfocus channel. You'll find more quick dives and deeper explorations into advanced science, physics, technology, and philosophy here. I'm a physicist through and through, and I aim to give you the real deal without the pop science fluff. Click subscribe, leave a thumbs up if you enjoyed this, and let me know in the comments what you think about this theory. See you in the next video.